Okay, in section 9.3, we're going to focus on odds, continuing the topic of probability. Um, and this will finish up this, and then we'll go into 9.4 next, where we look at some permutations and combinations. In this section, I want to first, before we really get into the material, I want to show you a few things from Lead Forward that can maybe help you when you're doing your lesson plan. So if you're interested in doing your lesson plan on the probability topics, the grade that you're going to need to look at is 7th grade. That's where the bulk of our probability standards are. And a lot of things that used to be introduced earlier are now first introduced in 7th grade. So I just want to show you that. If you go to Lead Forward to the resources, Lead Forward is just a really good company and place that have organized all of the TEKS for us. And so I know you can't see this entire page here, but I'll kind of pull it over so that you can see. If you go down into reporting category 1, that is the probability category. This is the year where a lot of probability is introduced and also tested. There are 6 questions on their STAR test over probability. And as you look at these readiness and supporting standards, you're going to see a lot of the things that we've been doing in Chapter 9. And so any of these are game for your lesson plan. If you go and look on Teacher Pay Teacher or Pinterest or in our textbook, you're going to get a lot of really good ideas, worksheets, activities, different things to do in your lesson plan. So I encourage you to pick one of these probability topics. They always make really nice lesson plans. If you read one of these standards and want a little bit more information on the standards, we have recently purchased the field guides. This is a paid subscription for these documents, and these documents basically will go into all of the standards in depth and kind of tell you what you need to teach, mistakes students will make. So this is something I'm going to have to send to you. If you want one of these, feel free to email me and I will send you the field guide that you're asking for. Let me just show you what these look like. So I've gone to the probability field guides. And again, I know this is cut off a bit and I apologize. It's just the screen size that I can record from. But as I look here, this is a 9-page document going in depth over the probability topics. And so the first one we see here is this supporting standard. And when you look right here in the top left corner, this is a scaffolding. Since it doesn't scaffold back, for example, if we were looking at one of the fraction standards, it would take you back all the way probably to 3rd grade and then show you what it looked like in 4th grade and then in 5th grade, so forth. And it scaffolds right here in this top left corner. Since this one doesn't do that, you can see that this is introduced the first time in 7th grade. And so it just tells you what we're talking about here. Below it, we have a stimulus box. Below that, we have academic vocabulary. And below that, if there was ever a question on the STAR test that they just found really interesting and it tested this particular standard, they're going to tell you, okay, this one was on the 2016 test. It was question number 3. And you can also go and pull up those questions on Lead Forward site and use those in your lesson plan if you'd like to as well. On the other side of the page, we have role and concept development. So let me see if I can get this over here. Whoops. Get back to this page. I'm having a hard time showing you guys this, so it's not cooperating with me too well. All right, I'm just going to read what I can to you and kind of show you what it is, and then I'll send you the documents where you can see the whole thing. So this is a supporting standard, so it'll tell you which one of the readiness standards it supports. It'll give you the relevance of this. It'll tell you when to teach this. And what I think is most helpful is this instructional implication. It kind of goes into this detail of how you should teach this, maybe examples that you should use, and so forth. And then the last thing that these documents do is they show you where students are going to make mistakes, which can be very helpful if you're going to teach this. So we have one of these documents for every one of the standards. And so here you can see this one's a readiness standards, and there is some scaffolding here in this top left corner, but it all scaffolds back to 7th grade. Other ones will take you back to whatever grade it was first introduced. But this one scaffolds back and it shows you would teach 7.6a, then B, then E, and then come to I, and it kind of scaffolds that way. But same thing, you have these instructional implications, and that piece right there is huge, especially if you're a new teacher and need some direction on how to teach this material. So just want to show you that for your lesson plans, and now we'll go back to your notes and go through this material. So what we focus on here is odds. This is just a 5-page reading from your textbook, so I highly encourage you to read those 5 pages. I've listed some additional problems. That textbook homework is completely optional. It's if you do the My Math Lab homework and you want a few more questions to practice, that's something that you can do, but again, it's completely optional. Okay, when we consider probability, probability is, okay, so for example, if I say, what's the probability of rolling a 2 on a dice? You would say, well, there's 1 2 on a dice, so that's 1 side out of 6 total, so the probability is 1/6. Odds is different because probability is out of total, but odds is very different. It's a comparison. It's how many outcomes are there that I want compared to how many outcomes that I don't want. So if I say, what are the odds in favor of rolling a 2 on a dice, you would say 1 to 5. And it's a comparison, it's a ratio, it's not a fraction. There's 1 outcome that works, there's 5 that don't. And so it's not at a total at all like probability. Probability of rolling a 2 is 1/6. The odds of rolling a 2 is 1 to 5. And so that's, in a very basic example, what odds is. If you want, number 1, the odds in favor of an event, it's the probability of it happening divided by the probability of its complement. But an easier shortcut way is just to compare your favorable outcomes to your unfavorable outcomes. If you want odds against, you're just going to do the opposite of that, and you're going to write your unfavorable outcomes compared to your favorable outcomes. And so it really is very easy. It's written as a ratio. Remember, ratios can be written to where it looks like a fraction. So let's do an example, and I'll show you the 3 ways that it can be done. So we'll do a basic example. What are the odds? So I want the odds of flipping tails. So odds, oh, and I need to add in here. What are the odds in favor of flipping tails? So if I consider a coin, one side is heads, one side is tails. So the odds in favor of flipping tails, well, there's 1 tails to 1 heads. There's 1 that works, there's 1 that doesn't. If I say what's the probability of flipping tails, that's 1 out of 2. 1 side works out of 2 total, but odds is not at a total. It's a comparison of what works to what doesn't work. Another way you can write this is 1 to 1. You have to leave that as a fraction, or in that fraction form. It's not a fraction, it's a ratio, but you can't reduce that to 1 because it's 1 to 1. You're not going to do the division. Another thing you can do is write 1 to 1. So that's all the things that work to do that one. What's important here on the bottom, the odds in favor, it is a comparison. It is a ratio. It is not a fraction. Probability is a fraction. Odds is not a fraction. All right, let me clean this up and then we'll go to the bottom of this page. When we get to the bottom, we're just going to do a few examples, and I think you'll find this to be quite easy. And let's see. All right, so going on to the examples on the bottom here, it says find the odds in favor of the events occurring. And so we're doing odds in favor, and I'm going to probably go ahead and throw in a few odds not in favor or odds against, just to kind of show you an example of that. So first one, I want the odds in favor of rolling a number less than 3 on a die. So when I consider a die, it has 1 through 6. Numbers less than 3 would be the 1 and the 2. So since it's odds in favor, I'm going to do favorable outcomes to unfavorable outcomes. there are 2 outcomes that are less than 3 on a dice compared to 4 outcomes that are not less than 3 on a dice. You do go ahead and reduce these ratios, so we would reduce this to 1 to 2. You could write it as 1 to 2 or 1 to 2. Any of those would work. If I switch this up and say, what are the odds against? When you do odds against, what's going to happen then is you're going to do unfavorable to favorable if you ever see that odds against. And so that would end up being the 2 to 1, the opposite of that. There would be 4 that don't work, there would be 2 that work, and when you reduce it, you would get 2 to 1. All right, the next one, we're going to go back to the same example we talked about above, tossing tails on a coin. So we want the odds in favor. So we're going to do the favorable outcomes again to the unfavorable. There is one side on a coin that is a tail. There is one side that is not. You can also write that as 1 to 1 or 1 to 1. Last one on this page, drawing a heart from a standard deck of cards. So when we consider all the cards, remember there's 52 cards in the deck. There's 4 suits. So remember there's clubs, spades, hearts, and diamonds. If you take that 52 and divide it into the 4 suits, you'll know that there's 13 cards that are hearts. So the favorable outcomes would be, okay, there's 13 cards that are hearts. If I said what's the probability of getting hearts, it would be 13 out of the 52. But we're not doing probability, we're doing odds. So the odds is there's 13 cards that work compared to how many that don't work. Well, the rest of the cards don't work. That's 39 cards left. This does reduce to be 1 to 3. You can write that as 1 to 3 or 1 to 3. All right, let's go ahead and go to the second page here. All right, so we'll go up here to the top of the second page. And it says, a family plans to have 4 children. What are the odds against having 3 boys and 1 girl? And we've already in the past lessons done some tree diagrams, and I want to continue that on this because it makes it so much easier to see what are all of the different outcomes if a family plans to have 4 children. And so what I'm going to do is I'm going to get a whole clean page to do this, and we're going to draw a tree. So we want the odds against, so we're going to be doing unfavorable to favorable. We want 3 boys and 1 girl. So let me get a clean page here, and I'm going to do the family tree. So on my first child, I'm either going to have a boy or I'm going to have a girl. If I have a boy first, my second child could be a boy, it could be a girl. If I have a girl first, I could have a boy or a girl second. So when you follow this, you know, you could have boy, 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 girl, girl, boy, girl, girl. So this is the first and the second child. Then we got to add the third child. So I could have boy, girl, boy, girl, boy, girl, and boy, girl. And then I need to do the fourth child, boy, girl, boy, girl, boy, girl. Gonna run out of room here. Boy, girl. Now I'm really out of room. Boy, girl, boy, girl. You can continue this on your own. It's quite easy. But what we need to do is we need to go down paths. And so like right here, this would be the path of where you have boy, 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 boy. And then, you know, you could go here, boy, 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 girl, and so forth. And so you can see what all of those paths would be. When I look at this, I can see from the endings here that as far as different combinations, I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 16 different combinations, 16 outcomes total. And you could write them all out if you want. Boy, 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 girl, boy, boy, girl, boy, 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 girl, girl, so forth. But instead of writing them all out, I want to look at what I'm looking for. I need 3 boys and 1 girl. So I'm going to try to look into my tree here and find, oh, here I see one. This is boy, 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 girl. This one right here would also work. So boy, boy, girl, boy. I need 3 boys and a girl. Here, this one would work too. Boy, girl, boy, boy. And then here, girl, boy, boy, boy. So I'm going to write those out so you can see. And those are the only ones I see that have 3 boys and a girl. So that first one, let me get back to a pen instead of this highlighter. So we have boy, 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 girl. We have boy, boy, girl, boy. We have boy, girl, boy, boy. And then we have girl, boy, boy, boy. So those are the 4 outcomes that I see that have 3 boys and 1 girl. Because this problem said odds against, we're doing a comparison. Because it's odds against, we need the unfavorable outcomes to the favorable outcomes. There are 4 outcomes that work for this. That would be mean that the other 12 outcomes, making the 16 total, don't work. So if you look at everything that I did not highlight in green, those are all of the ones that did not work. This does need to be reduced. We can't divide it and say it's 3. We have to keep it as a ratio. So we reduce this to say 3 to 1. Again, we can write it as 3 over 1 or 3 to 1. Any of those work, but that would be your answer for that problem. And then the last little thing that we have here on this lesson is when you know odds, you can go backwards and figure out probabilities. And it's really, really quite easy. So if you have the odds in favor of M to N, then you can switch it, because what should happen, and I hope you've already seen this, is if you add your favorable and unfavorable, that's the total. So let me show you an example of that. If I say, what are the odds of rolling a 2? What are the odds in favor of rolling a 2? That's 1 to 5. But these 2 total make up the 6 total sides on the dice. If I say, what are the odds in favor of flipping tails? There's 1 tails, there's 1 that's not tails, but these 2 together make up the 2 total sides. So if you know your odds, you can add them and get that total and go back to probability, because probability is out of total. So an example for this is, if the odds in favor of Shane's winning the race are 4 to 7, what is the probability that he will win? So the odds in favor, there's 4 outcomes that work, there's 7 that don't, but when you add those 2, you get the total. So the probability that you would have a win would be 4 out of, when you add 4 and 7, that's going to be 4 out of 11. Just like here, the odds of rolling a 2 are 1 to 5, but its probability are 1 out of 6 when you add those. What are the odds in favor of flipping tails is 1 to 1, but the probability of flipping tails is 1 out of 2, because you add those 2 to get the total. Even if we do the card one, the odds in favor of getting hearts, remember that was 13 to 39. But when we add those, we get the 52 total cards. So the probability would be 13 out of 52, and then of course you could reduce that to 1/4. So a pretty easy section here. You should be ready to complete your homework. Remember, if you ever need more instruction, go to the multimedia library in my math lab, and there's more videos as well as a PowerPoint that can help you.